Hello, welcome to my channel Smart Techie. In this lecture, we'll solve numerical problems based on obstacle in chaining and how it is carried out in different cases. So we have covered the numericals part 1 in the previous lecture, and today we'll start with numericals part 2. Okay, so to continue, a survey line AB passes an obstacle. So this is an obstacle which it is passing. Which line is passing? A and B is passing an obstacle. Okay, and there is a perpendicular set at A and B, that is BC, which is 200 meters long. So they have given 200 meters long. And from C, angles BCD and BCE were set out at 60 degrees and 45 degrees respectively. So what they have asked us to determine the lengths which must be chained off along C and D, okay, and C and E, in order that ED may be in a line with AB produced, and also determine the obstructed length. So which is the obstructed length here? We have this B to E is nothing but an obstructed length. We need to determine this length, and also they have asked us to determine C to D and C to E, so that these 2 points are in a line of AB. Okay, when it is produced, it should be in a straight line. So we can continue this by considering a triangle BCD. So if I consider triangle BCD, so in this case, this is my triangle B, C and D. So here I know this is 90 degrees and here the angle is 60 degrees. When I am considering BCD, this total angle is 60 degrees. So I can take it as cos 60 degrees is nothing but cos theta is nothing but adjacent side by hypotenuse. So which is my adjacent side? BC is my adjacent side. Okay, and hypotenuse is CD. Okay, I can take this and I can solve this equation by substituting the values. So CD is nothing but BC, okay, upon cos 60, that is nothing but BC. I have 200 meters which is already given, and cos 60 degrees, that is nothing but 400 meters. So the length of C and D is nothing but 400 meters. So in the similar manner, we'll consider next triangle, that is triangle BCE. Okay, because we need to find the length of C and E also. So what is the angle BCE? The angle is 45 degrees. So that is also cos 45 degrees is equal to BC, that is the adjacent side, upon hypotenuse side, that is CE. Okay, so CE is nothing but BC. Okay, when I cross multiply it, this cos 45 degrees, that is nothing but 200 meters which is already given, cos 45, it is 282.84 meters. Okay, so now next I found out this distance CD and CE. Now they have asked me to find the obstructed distance, that is B and E. So here it is 90 degrees, okay, and here it is 45 degrees. So I can consider tan here. So I can consider triangle, next triangle, that is B, C and E. In this case I can consider tan 45 degrees, that is nothing but opposite side. Okay, opposite side is BE upon adjacent side is BC. So when I substitute here, BE is nothing but BC into tan 45 degrees 200 into tan 45 degrees is nothing but BE is 200 meters. This was very simple. Next, a survey line is obstructed by a high building. To prolong the line beyond the building, that is 150-meter long, and perpendicular BC is set, okay, which is 150 meters long, is set at point B. So there are two lines C and D, and C and E are set out at an angles of 30 degrees. Okay, so B, C and D is 30 degrees, and B, C and E is 40 degrees. Two lines C and D and C and E are set out at angles 30 degrees and 40 degrees with CB respectively. Okay, so determine the length of CD and CE so that they are in the same line of AB. Okay, prolongation of AB. If the chainage is of B is 100 meter, find the chainage of D. So what we need to find? We need to find the chainage of D. So what they have given, chainage of B is 100 meter. That means the survey has been started from point A, okay, till point B. The chainage is 100 meter. So this distance is nothing but 100 meters. So when they ask the chainage of D, so it is from the starting point to D. So the chainage of D is nothing but the distance between A point to D point. Okay. So similarly, we'll consider a triangle BCD, okay, wherein we have cos 30 degrees is equal to BC, okay, that is the adjacent side upon the hypotenuse side. So here we have 150 upon cos 30 degrees, that is but nothing but 173.205 meters. Okay, so next triangle will consider BCE, okay, that is nothing but cos 40 degrees, that is BC upon CE. Okay, so CE is nothing but 150 upon cos 40 degrees, that is 195.81 meters. Next, so what we need to find? We need to find the distance BD. BD is nothing but, with Pythagoras theorem, we get square root of CD the whole square minus BC the whole square. So what is CD? As we calculated, it is 173.205, okay, the whole square minus 150 the whole square. So we get BD is nothing but 86.602 meters. Okay, so this is the distance of B and D. So as I said earlier, we need to find the chainage of D. That is nothing but AB distance, that is chainage till B, and plus this distance. So what will be the distance? Chainage of B is nothing but 100, which is already given, plus this distance, that is B and D distance, that is nothing but 86.602 is equal to 186.602 meters. So the next numerical, a river is flowing from west to east. So the river is flowing from west to east. This direction is west and this direction is east. So we need to determine the width of the river. So the width of the river is this distance. So to find the width of the river, what we'll do, we'll consider a perpendicular, okay, a perpendicular point D, which is perpendicular, so that we can find the distance C and D, that is nothing but the width of the river. So what they have given 2 points A and B are selected on a southern bank. So for example, if this is west, east, so what we have, this is north, this is west, this is east, and this is south. So they have said 2 points at the southern side. So A and B are the 2 points, okay, and they have said bearing with respect to point C. So what is a bearing? See, bearing is with respect to north direction, okay. It is nothing but it is an angle measured with respect to the north direction. So here in the point A, if I consider this is north, this is south, this is east, and this is west, and there is a line, okay, that is A and C. So what they have calculated, they have given the bearing. So this is the angle measured with respect to the north direction, that is 40 degrees. Okay, so but what we require is angle A. We require angle A, that is nothing but C, A and B. So we need to find this angle. So here the total angle is 90 degrees. Okay, so when we deduct this bearing from the total angle, so we get angle C, A and B, that is nothing but 50 degrees. Okay, so this angle is 50 degrees. So similarly here also, the total bearing with respect to north direction is 340 degrees. So this angle, this distance or this angle will be 360 minus 40. That will be 360 minus 340, that is nothing but 20 degrees. So this is 20 degrees. But this total angle again, it is 90 degrees. Okay, because see, if we consider north, south, west and east, so here we have this line from this point, that is B to C. So this angle is measured from this north direction till this line. So this total is 360, okay, and minus 340 we get this distance. But what we required is this angle, okay, we require this angle. So I'll do 90 minus 20, that is nothing but 70 degrees. So here I'll have BCA as 70 degrees. Okay, so when this is 50, when this is 70, what will be my angle C? My angle C will be 60 degrees. Okay, so next I can consider by sine rule. Okay, by sine rule, what is the sine rule? The side, okay, upon divided by the opposite angle of that side. So what I can say that by sine rule, I can find at least one distance, that is A and C. So by sine rule I can consider AC, okay, this is AC. This angle, how much I have? I have 50. This angle is 70 and this angle is 60. Okay, so I have this. So AC is nothing but this is AC. The opposite angle is A, B and C. Okay, so it is sine angle ABC is equal to BC divided by sine opposite angle BAC is equal to side AB upon sine angle ACB. So I'll just equate these two, that is AC, okay, upon sine 70 degrees, that is nothing but AB upon sine 60 degrees. So what do I have? When I cross multiply, I have AC is 100 into sine 70 degrees divided by sine 60, that's equal to 108.5 meters. Okay, so next what I need to find the width of the river, that is width of the river is CD. Okay, so what I'll do in this case, next triangle which I'll consider is I'll consider ACD. So in ACD, what I can find, I can say that sine 50, okay, is equal to CD, okay, upon AC. Because I know the distance of AC here, I can substitute. So CD is nothing but AC into sine 50. That gives me 108.5 meters into sine 50. Okay, that is nothing but 83.116 meters. So the width of my river is nothing but 83.116 meters. Thank you.